I recently made a post explaining how to create an APK and a .app for iOS from your computer using the native toolchains Gradle and Xcode build. And it has come to my attention that many React Native developers have no idea they can actually create these artifacts locally, and I actually got a lot of requests for this video, so this is it. By the end of this video, you'll be an expert in release artifacts. You'll know the difference between them, how to produce them, when to use which one of them, and if you stick till the end, you'll get a cloud skill that will help you create release artifacts just by prompting. Let's get into it. Before we dive in, this video is sponsored by me. If you want to become a master in React Native or just support the channel and my work, consider becoming a pro member at codewithbeto.dev. You get access to everything, including our latest and most capable React Native template called Platano. Already comes with payments, works on Android, iOS, revenue ready. Just run this command and get started. And some of the early users of Platano are sharing already really nice feedback about it. Most engineers are actually using it just as an example or to ship a completely different application, not an AI image app, and I completely agree. I'm actually using Platano for any new real project that I'm shipping. In case you're new to mobile development and you are using AI, check out my book From Idea to App Store with Cloud Code. All the links are in the description. Now let's get into it. Okay, so how React Native builds work. React Native allows you to create iOS and Android apps fully native, and each platform has its different type of builds and artifacts. So we first need to understand how that works. Basically, an artifact is the file that your build process spits out. These are the four types of artifacts. For Android, you have .apk, which stands for Android package, and it's a self-contained installable. Drop it in any device and it runs. Then we also have the .aab file, Android app bundle. This one is used by Google Play. So you give the .aab to Google and they take that to generate a smaller per device APK at install time. And iOS works the exact same way. You get a .app, it's called iOS app bundle, and that's the compiled app that runs on the simulator or on your device through Xcode. And then when you are ready to ship that to production, it's called a .IPA. It's basically a .app, but signed with certificates. So those are the four types of artifacts. Now you might be wondering, how does it actually look, right? These are type of files. So I took a screenshot. This is Platano, the template that I just showed you. It's not signed, and I think that's why you get this icon here. And an APK, that's how it looks, 138 megabytes. And this is the real thing. This is the IPA, also known as the archive of your build, and the AAB. So for Android is 90 megabytes and this one is 195 megabytes. That's how it looks. Okay, so a quick mental model to understand, because you might be wondering, oh gosh, 200 megabytes for a simple application, that's a lot, but that's not actually what users installed. The archive, it's the source of truth, right? And the archive can be used to generate the app file or the APK that is installed on the real device at install time. So when the user presses the install button, Apple and Google are going to look at the main artifact and just grab the piece that is compatible with the device that is requesting the application. So let's say in an iPhone 17 Pro, it's going to be around 40 megabytes once you install the application. So the archive is the source of truth for every variant. Okay, now let's talk about how you can create one of these builds, right? One of these artifacts. Well, your machine actually decides what you can build. This might be obvious for a lot of you, but you might be surprised of how many comments and questions I get every day, people asking if they can build an iOS application on a Windows machine. And the answer is no. Apple requires Xcode for iOS, and Xcode only runs on Mac OS. If you don't have a Mac, you cannot build an iOS application locally, right? You can still use the cloud to build your Expo app using a service like EAS, and we are going to talk about it. But if you want to develop an iOS application, I would highly recommend that you get a Mac. That's step one. That said, if you're just targeting Android, you can use Windows or Mac. Android Studio is available for macOS. Okay, so there are two ways of creating these artifacts. You can create the build locally using your computer, or you can use the cloud and services like Expo application services. So when you are building locally, you're gonna be using the native toolchains. For Android, you use Gradle. For iOS, you use Xcode. The advantage of local builds is that it's extremely fast, it runs on your computer, but you need to have the setup already done. Those are the two ways of building. Now let's take a look at the native Android project that you get when you pre-build your application. So a React Native Expo app is going to look like this. This is the Platano template that I was showing you before. And if you have been using Expo, you know that you can run this command npx expo prebuild. When you run this command, the Android and iOS folder are going to be generated. This native project is generated by Expo based on the dependencies that you are declaring in your package JSON based on your code, and this is just a native Android project. You can think of your Expo React Native application as a mono repo with multiple projects, the Android and iOS folder. The Android folder and the iOS folder are the folders that make release builds possible, because that's the native code that you compile. Without it, you cannot do it. So how you can build Android locally? It's very easy. You just cd into the actual Android project by opening your terminal, cd Android, and boom, you are inside the native project. The Android project actually comes with some tooling like Gradle. So Gradle, it's a tool that allows you to compile the application, and Gradle, you can install it globally on your machine, but actually you don't have it installed, but that's okay, because if you pay attention here, the Android folder already comes with its own Gradle, and it's called Gradle wrapper, which means you should call it with a W here, Gradle wrapper, and then you can use this little artifact that comes here. If you take a look at the wrapper properties, you can see the version. It's 9 in this case. And then, for example, I can say version, hit enter. This is just gonna tell me, oh yeah, it's version 9, which I already knew here. So you get access to this just by cd into the Android folder. You can use Gradle to create APKs and .aab artifacts. To generate the APK, you just use Gradle wrapper running the command assemble release. Once the command is done, you'll find the APK inside the app build outputs. Here's the APK. And I actually just realized that this is a debug build. That's why it's showing me these developer tools from Expo to connect to the server. And this is because I'm inside the debug folder, but if you go to the release, you also get an APK, which is the one that you should use for a release build. This one is the actual standalone one. So Expo is not going to install the Expo dev client when you have a release build. So this is going to reinstall it. Let's open it again. And now this is the actual application. Let me allow permissions here, and boom, this is a standalone application. I can close it, reopen it. Everything works just great. It's super fast because it's the real thing, right? This is great for testing and for sharing quickly. To generate the .aab, just run Gradle wrapper bundle release. That will generate the sign.aab for the Play Store. So let's move on to the iOS folder. This is again a full Xcode project for Mac only. I'm gonna minimize my Android folder. Let's take a look at the iOS folder. It comes with a pod file and all the native stuff that you need for this specific project, depending on your dependencies, depending on your code. This is the native stuff. So again, you can open the terminal, cd into the iOS folder, and start, using, for example, Xcode build. So once you install Xcode, that actually installs Xcode build, which is a CLI tool that you can use for building your application. Now this is a little more verbose, and I actually created a blog recently on how to build your React Native app locally. So for iOS, this is a little more verbose. You need to pass Xcode build and then the workspace, the scheme of your app, the configuration that you want to use. In this case is release. Otherwise, if you create a debug build, it's going to include the Expo dev client, which is going to wait for the server to be running. Otherwise, it's not going to work. But it needs to be released. You need to set the SDK as iPhone simulator, and then code signing needs to be no. So let me show you that in practice. So once you have the command, you can put it into a script and run it, and this will generate it. Now this is for creating a .app release, right? This allows me to install it on a simulator as a standalone. This is good for end-to-end test. I recently made a video on how to use Maestro for end-to-end test, and I use this .app to fully test my onboarding flow. Make sure to check out the video. I'm gonna leave that in the description in case you're curious. But yeah, this is the command. So you can just run something like this with the values of your project. The command has completed. You will find your app file inside the iOS folder, build, again, build, products, release folder, and then platano.app. Let's open this in the Explorer. Like I said before, it's going to look something like this, and then you can drag it into any simulator. So I'm going to remove this just to show you that once you drag it, it's going to install it, and you can open it. And here we have it. So this is the real application. The first time that you open it, this is how it looks. This is the onboarding. You enter your name and all that good stuff. This is actually the template. Make sure to check it out. It's amazing. It's really gonna save you a lot of time. Okay, so that's a build, release build for a simulator. It's not signed, right? It's easy to create, it's fast, and you can install it on simulators. It's great for end-to-end test. You can check out my blog. I'm gonna leave the link in the description where I teach you more in depth and give you the code examples that you can copy paste. I also created a Claude skill that helps you create the scripts with your project name, so you don't have to manually type it. So Claude is going to generate the scripts for you. You can just run them, and then you get the APK and .app locally without doing anything. So make sure to check out the skill. But this is only the .app, right? So for iOS, it's a little more complex because iOS requires you to sign your application when you are ready to deploy it, right? To install it on real devices, you need to distribute it through TestFlight or the App Store, and that's the .ipa. So the way you create a .ipa, it's by compiling first your application and generate the .app bundle. Once you have that, you need to sign it. Once you sign it, it becomes the archive, okay? And then you need to export it as a .ipa. Once it's basically a .app, but signed. That's the IPA. Now you can also create the IPA using Xcode build from here. Actually, that's more complex, I would say, and it's way easier just to use Xcode. Once you have Xcode installed on your computer, you can run this command, xed iOS. Basically, I'm saying, hey, Xcode, open the iOS folder, and Xcode is going to open it. This is how it looks. So this is my Platano application. It comes with pods, and then the actual app here. It has actually two targets, one for the share extension that I have. And here you need to just select your team to make sure that the signing and the artifacts are working correctly. Just select your team with your Apple account, and that's how you signed the build. And then once you're ready to deploy this to TestFlight, you can select any iOS device here from the dropdown, and then go to the product, there it is, and then archive. So archive is going to generate the archive that I just mentioned here, the Xcode archive, ready to export for TestFlight. So once you run this command, I'm not going to run it because it actually takes like a couple minutes. But then once you do that, you can go to Window and then select Organizer. And this organizer is going to show you all the Xcode archives that you have. So I compiled this previously. This is my archive. You can open it if you want in the Finder, and this is how it looks. I showed you before, this is the real thing. This is the archive, and you can send this to Apple. So to send it, you can just press this distribute app, select App Store Connect, and I'm going to cancel it because I'm not ready to publish this yet, but this is actually how I release my AI tattoo application, for example. I just compile it locally and distribute it through Xcode. And then once you submit that to TestFlight, you can install it or any testers in your team. Okay, so that's how you create the .ipa. Now, let's talk about EAS. As you might know, Expo offers many services. One of them is EAS Build. Basically compiled and sign your Android and iOS application in the cloud. The way it works is simple. You have your project, trigger a new build using the EAS CLI, and then that uploads your project to the cloud where Expo can build your application on a Mac machine, and then it gives you the artifact. So to build for iOS, you can run the command EAS Build platform iOS, EAS Build platform Android. Now, the killer feature here is that if you don't have a Mac, but you want to compile your application for iOS, you can actually trigger this command from a Windows machine. Once you trigger these builds, you basically will get the same files that I show you. Then you can distribute them, or you can also use Expo to submit the application. It's a different service, but we're talking about builds right now. Now, Expo is actually free to get started. You can just create an account, and by default, you will get 15 Android builds and 15 iOS builds per month. In my opinion, that's more than enough for a side project, right? But it depends on how much you're building. If you build more than that, you might consider upgrading to this starter plan, which is $19 per month and includes $45 on credits. The way it works is that if you build an Android bundle on a medium worker, meaning a machine that is medium size, that costs $1. Larger machine means the build is going to finish faster, but it costs $2. For iOS, the medium worker costs $2 and a larger worker $4 per build. So if you want to use the large worker, it's very fast, but it costs $4. So if you build 10 times, that's 40. So this is something to consider if you're using EAS Build. Now, the good thing about Expo is that you can use the 15 builds and then you can build locally as well. Expo provides a flag for running these commands, EAS Build platform iOS, with the local flag, and that will use your computer to build the application, and that's free. It doesn't count toward your usage, and it's basically like running it using the native toolchain. Just Expo wraps everything into one command and you get the same artifact locally. You can do that as well. I personally recommend that you do that, especially if you don't want to use all your builds. You can build locally, and then once you're ready once you know that your application compiles and works nicely and you're ready for production, maybe just use EAS to build and submit. So overall, there are mainly 3 ways of building your application. You can build locally. It's the fastest iteration once your machine is ready. And if your machine is capable, if you have a good machine, it's faster building locally, and it's free. There's no queue, no waiting time, full control over the native tooling. And I would say that this is best for solo developers, especially if you have a nice Mac. And that's personally what I do most of the time. Now, the second option is using EAS with the local flag. Like I said, you can build locally. It basically runs the same workflow, but in your machine. So still, you need a Mac if you want to build for iOS. It has the same credentials handling, no cloud minutes consumed, great when you want EAS conventions but have the local horsepower. And then the third option I would say is EAS Cloud. Especially if you're on a team, you are not going to be paying for it, you just might as well just use Expo. It's easier, just one command. Again, you can trigger iOS builds from a Windows machine and a CI/CD integration. And I recommend that you use EAS Build, especially if you have a large team, I would say 3 or more people, because as the team grows, you need to run end-to-end tests, trigger builds, make sure that nothing is breaking. So EAS definitely will save you more time than having to juggle all the builds locally. That's all I have for today. I hope this video was helpful and informative. Make sure to check out my courses, Plátano, the template to ship faster, and my book. All the links are in the description. I'll see you in the next one.